Hi, this lesson is over similar solids, or 3D figures. We're going to talk about the ratio of the parts, the ratio of the areas, and the ratio of the volumes. Just a reminder that similar means same shape but different sizes. So you have two figures that are exactly the same proportions, except for one is bigger than the other. And solids mean 3D figures. So here's an example of two cylinders, and their sides, their heights are labeled 3 to 2. So that's the height over the height. So our scale factor is 3 over 2. And so we're going to use this scale factor to help us with the ratios of their areas and their volumes. So here I have 3/2 is this radius, and this radius is a 1. So if you do that, 3/2 over 1, you get 3/2. And so all of their corresponding parts are going to be in this scale factor. Like I just said, the ratio of their parts is equal to the scale factor, and that's how we find the scale factor. The ratio of areas is the square of the scale factor, and the ratio of the volumes is the cube of the scale factor. So here, like if your scale factor was A over B, all of their corresponding parts are also going to have this ratio, A over B. The ratio of the areas will simplify to A squared over B squared, so it's the square of the scale factor. And the ratio of the volumes is A cubed over B cubed. And so everything's got to be cubed because it's 3D. So these are the rules that we're going to follow, and I'll show you the examples. Our first example says if two similar solids have a scale factor of 5 to 4, what is the ratio of their surface areas? All right, so let's think about, we want to know what our scale factor is. So it's 5 over 4. And we know that the areas, the ratio of areas, is the square of the scale factor. So we'll take our 5 over 4 and square it. And that equals 5 squared over 4 squared. So the ratio of our areas is going to be 25 over 16. So again, this is our scale factor. This is the scale factor. And then when we want the ratio of areas, we square the scale factor. And then we do the math and get our answer. What if we were asking for the volumes? We would take our scale factor, 5 over 4, and for volume, we have to cube our scale factor. So this would be equal to 5 cubed over 4 cubed, which is 125 over 64. So 5 times 5 is 25, times 5 is 125, and 4 times 4 is 16, and 16 times 4 is 64. So again, we have our scale factor. Here we're going to take our scale factor and cube it, and then we get our answer. 125 to 64 is the ratio of the volumes. We can also write this with the semicolon or the colon symbol, so it's 125 to 64 is another way to write that ratio. Okay. The next example says if the radius of a sphere is doubled, the volume is how many times as great? All right, so if we have a sphere with a radius of r, okay, our volume would be 4/3 pi r cubed. Okay, but if we doubled it, our radius would be 2 times r. And so in this case, our volume is going to be 4/3 pi 2r cubed. And so when we look at this, the only thing that's different, if I made a ratio out of this or a fraction, I would be able to cancel out the 4/3, cancel out the pies, and then I would just have this r cubed over this 2r cubed. So let's look at this. What 2r cubed is. We have 2 cubed, r cubed. Okay? So this 2 times 2 times 2 is 8, so 8r cubed. So basically, if I was going from this to this, I would basically just have to take the volume and multiply it by 8 if my radius was doubled, because that's 2 cubed. If I was tripling it, then I would take the 3 and cube it. This last example says find the ratio of the surface areas. So we have two spheres and it shows us what their radius is, and so we can find our scale factor. So the first thing we want to do is find the scale factor. Okay, so if we take 9.6 over 3.2, we can reduce that, and it does equal 3 over 1. So our 3 over 1 is our scale factor. So when we want to find the surface area, the ratio of the surface areas, we take the scale factor and we square it because it's areas. If it were volume, we would cube it. So that is 3 over 1 squared, which is 9 over 1, or 9 to 1. So this would be our ratio of the surface areas. I hope this helps, and I hope you guys have a great summer.